Hello everyone and welcome to this session, which is part 2 about how to convert a paper topographic map into a digital terrain model that we can use for different applications. I'm going to go through all the steps from A to Z using ArcGIS software today. It is very important to watch part 1. In part 1 I covered the main stages for converting a paper map into a digital terrain model, and these are the stages that I explained. So we will start from scanning, and then we will do georeferencing and digitizing the contour lines, and finally we are going to generate the final DTM. So if you haven't watched that yet, please do watch part 1 so that you will have a good understanding about the whole process from A to Z. So let's get into it. So now this is ArcMap, as you know guys. I'll start now adding my scanned map from here, add data. And now I need to navigate to the folder that I have my scanned map in it. It is here, DTM tutorial. Now this is my scanned map. I will add it from here. Just click add. Okay, here I would say yes. I will let the software create the pyramids for this map. Then OK. And this is my map. As you can notice here, guys, I have cut out all the outsides of the map. I have just the actual map itself so that I can use it later on if I would like to add the map for this area here and the map for this area to create a larger DTM for the larger area. This would be easier for me. But for now, just to let you know, I have cut out all the outside edges of the map. So these are the contour lines, as you can see here, with their elevations. It's a very nice and detailed map here, as you can see here. I have some mountain down there. Here I have the mountainous area. And this resolution is enough for digitizing the contour lines, these lines that we can see here. Before I do the georeferencing, guys, now I'm going to define the map projection for this map, and then I'm going to do the georeferencing. So for defining the map projection, there are a lot of methods for defining the map projection. This is one of them. You go to View, Data Frame, Properties. This will apply the map projection to all the data here. I will go to Projected Coordinate Systems here, guys. And then my data is a national grid. I will search for national grids here. I will expand this. My data is in the UK. I will look for Europe and then British national grid, which is this one. This is my map projection. So British national grid, I will apply and then OK. Now I have used the map projection. Now let's move to the next stage, which is georeferencing this map. Now I have this map ready. As I mentioned in part 1, the previous video, we need at least 4 points to georeference this map. I have all the coordinates of these corners of the map here, guys. Okay, I have written all of these on a separate sheet of paper. I have them already with me. Now I will start georeferencing this map. Okay, now I would like to add the georeferencing toolbox from here. Right click out there here, guys. If you just right click here, you will have all the tools that you have here. I will go to georeferencing, this one, and then click here. And this is the georeferencing toolbox, as you can see here. Now for this tutorial, I will just add 1 point. I will georeference 1 point, and then you can apply the same process for the rest of the points. So I will do this corner, and then you can do the same for the rest of the corners for your work. Now to pick a point, guys, from georeferencing here, you will go to Add Control Point here, click on it, and then you will have the cross sign like here. you need to be very accurate here in selecting the location of your ground control point. For example, now I will pick this corner, and then to enter the coordinates for this corner, I'm going to use now the degree, minute, second. I'm going to use the geographical coordinates now. Here I'm going to enter the degree, minute, second values for my first ground control point or the first corner of this map. The coordinates of all of the map corners and all the ground control points that I'm going to use are ready with me. Now I will start entering them one by one. I will do the first one for you so that you understand how to do this, and then I will move to the next stage. Now here, for my first corner, the coordinates are west. If you remember, it was west, not east, and then it's here 2 degrees, 26 seconds, and for the northing, 53, 56, and 42. So now I have entered the coordinates, the geographic coordinates for the first corner. I will click OK. Now I can't see the map because it's been shifted completely now from its local coordinate system to the real or to the actual coordinate system. To see the map is very simple. This is my map. Go here to the left of the screen, guys, here, and then right click on here and then zoom to layer. I will zoom to this layer now. I have my map back again, and this is the first ground control point. And then, guys, I will do the same for point 2 here, point 3, point 4, and if you need to add any point in the middle using these grid lines here, the coordinates of the grid lines should be known from the map itself. You can add some more points to make the georeferencing process more accurate. Now once you added all of your control points, you need to go here to georeferencing. Make sure that here you have your map. If you have a lot of layers on the left, make sure that the active one is your map, and then go to georeferencing and then rectify. Okay, so here, guys, you can change the cell size if you like, and this is the resampling method. If you would like to select any one of these methods, this is the nearest neighbor, this is the bilinear interpolation and cubic interpolation, so you can select one of these methods. And here the location of your output file, the rectified image or the georeferenced image or map, the type of it, TIFF, etc. The name, you can rename it, etc. And then click Save. Now if I go here to see, this is my saved file. This is the georeferenced map here. Okay, now I will try to open this map and to deal with it from now on. Now this is my georeferenced map, guys, here. The important thing that you have to look at after you georeference or after you open your georeferenced map here, the coordinates down there. Yeah. Now I have the actual coordinates here. When I move the mouse, as you can see here for this corner, it's 2 degrees, 27, 26 point something west, and then the northing is 53, 56, and 41, etc. So these are now the actual coordinates, geographic coordinates for this map. Now to change the coordinate system here from geographical coordinates in degree, minute, second into meters, we can go to View, Data Frame Properties, and then from General, you need to select here the display in meters. Okay, now I will apply. Okay, and here, now I have my coordinates in meters. So this is how to switch between two coordinate systems in degree, minute, second, or decimal degree, or meters, etc. It depends on your map and the units used for your area. Now we've done the second stage of this process, which is defining the map projection and georeferencing the data. Now the map is ready for us to move to the third stage, which is digitizing or tracing the contour lines one by one. And for that, I'm going to use the editing toolbox. From here, as I added the georeferencing, I'm going to right click somewhere here using the mouse and then to look for editor, this one, and then I will add this, click here. This is the editing toolbox. I have it here now, this one. Now before starting, we need first to create a file so that we can draw all of our contour lines in it. Okay, so this file might be shapefile or feature class. If you are experienced in geodatabase and feature class, you can use geodatabase and feature class. But now to keep it simple for the most of you, I will create a shapefile and then we'll start editing on this shapefile. We'll go to catalog here for creating the shapefile. Then try to connect to the folder where you would like to create your file. For example, I'm going to use this folder here, DTM tutorial, and then OK. I have now DTM tutorial here. Now to create a shapefile, right click on this folder using your mouse. This one, right click and then go to new and then to shapefile. Here, as you can see here, guys, I'll create now a shapefile. Click here, give it a name. What do you like to name it? Let's call it contour. And then the feature type here, it's important here to select polyline. It's not point, not a polygon. It is polyline. You can use this one. And then you need to provide some information about your spatial reference, which is the map projection that we have just done before georeferencing. There is an easy way to for the map projection from here, edit, and then you go here and then click here and then import the map projection. I will import this from okay guys, now this is the shapefile contour that we have just created, and here we are going to add all of our contour lines or trace our contour lines to be added here inside this file. So now we are going to go to the editing, start editing from here, guys. I will start editing. I will select the contour shapefile that I have just created and then click OK. And now guys, you will go here to the right of the editing toolbox here to create a feature. Okay, I will click here, create a feature. Okay. Now I will click on the contour file to make sure that I'm going to edit on this file that I have just created, the contour file, and then what kind of feature that I'm going to draw here. I would say line. I'll click this one, line, and now I need to start tracing the contour lines one by one, and I will do, for example, one for you, and then I will move to show you the final digitized map. So here, for example, I have here this top of the mountain. You would zoom to see the feature in a good way, and then I'll start tracing this contour line from here to here. Click, another click, another click, as accurate as you can in the center of the line. Try to be in the center of the line like this. Okay, now I'm tracing the whole contour line. Like this, guys. Okay, so this stage will take a lot of time and require some patience. It is a good exercise for your patience and accuracy. Okay, as you can see here, this is off the center line a bit. You can edit this later on. I will keep going now, quickly now, just for the sake of this tutorial. Now this is the last point. Now this is my contour line. Now to edit this contour line, guys, as I mentioned here, you would go here to pick this tool, the edit tool, and then double click on the contour line. And then you will have all of these nodes. You can just shift one down here or up and then adjust them as you would like. Okay, and then once you've done, double click, you have your contour line. And you will do this for all of the contour lines in your map. After you finish, you trace some or all of the contour lines. This work might take a couple of days, guys, so you can save it and then enter the values. As you will see now, you will learn how to enter the elevations for these contour lines and then save them, and then later on you can open this file and keep working on it. To provide the value, the elevation value of the contour lines that we are digitizing, we need to go to the file, contour here, for example, our file that we are working on, and then we are going to create a new field for entering the elevation values. This is simple, just follow these steps. Go to the file here in Arc catalog here, guys, and then right click on the file itself and then go to properties. After you go to properties, go here to the field name, just very simply add elevation. Write down, click down here and write elevation, for example. And this is my new field created. And here for the type of this is of course not a text, so select from the data type short and then select, just give it a name. I name this elevation and then apply OK, and I have this field. Now after I created this new field for elevations, I'm going to continue working on digitizing the contour lines, for example, and you can also from here get the file and then drag and drop here, for example, guys, and this is your contour line file here, and then you can start editing from here on your contour file, and that is the one, are the contour lines that I have just digitized, and this is my map. So now to add the elevation value for these contour lines, you have to start editing again. So because I saved these, guys, now start editing contour. Okay. Now you can go to the contour file, attributes. Right click on the file here and then open attributes table, and from here go to elevation. As you can see here, guys, you can add the values here, but how to add them? You need to select the contour line, get the edit tool, this one, and then one click on the contour line, and in this case we have this contour line here highlighted in light blue, as you can see here. And then now I know that from my map the elevation of this contour line is 530 meters. I would write down here 530 meters, and that's it. Now I provided the elevation for this contour line. For this one, for example, its elevation is 525. I will add here 525, etc. So this is how to enter the elevations of the contour lines, and once you've entered them, you can save edits. Now they have been saved here. Okay, now the values or the elevations of these contour lines have been saved in the shapefile contour. You can keep working, tracing the rest of the contour lines as well, like this, etc. Yeah, and then once you've done, you have to save always your edits like this, and you can enter, as I mentioned, the elevations from, again, the attribute table here. And let me say, guys, here in this stage you will decide on the best strategy for you to work on. You might digitize a couple of contour lines, for example 20, 30, 50, etc., and then to enter their elevations one by one here, or you might decide better to trace the contour line and then enter its elevation here one by one so that you will not miss any information. It's up to you to manage this stage of the work, but this is how to digitize and save your edits. After you digitize all the contour lines and enter all of the elevation values, okay, don't forget every time to save your edits, and now everything, all the information needed for generating the digital terrain model is stored here in this shape file. Okay guys, now after a lot of work throughout a couple of days, this is my final product here. This is the background map. I have all the contour lines, the traced contour lines here, as you can see. I will remove the map from the background. These are the contour lines that I have traced. As you can see, they are very nice. Now we need to generate a digital terrain model. A raster image represents the digital terrain model from this vector data, these control lines. Okay, have a look before we move to this stage. All of these elevations, as you can see here. Here I have the elevation of all of the control lines that I have. Look at this contour line. When I click here, guys, for example, this contour line will be highlighted here. Okay, so this contour line is here, this contour line is here, and so on. Let's close this. And now we need to search for two raster. I will get this one, for example, 3D Analyst. As you can see, I'm unable to use this tool. If you have this case, don't worry, just go here to Customize, and then Extensions, and then just tick 3D Analyst, and then close, and then go here, and now it will work. Here I have to enter the feature class, which is my contour lines. I call this contour 25K, which is the scale used. This is my input file. Now here, the location of the output file, I can just select. Let's say I'm going to save the output here in this folder, DTM tutorial, for example, and I will give it a name. Let's call it DTM 25K map, for example. Now save. This is my output file, and then let's go down. The cell size here, the resolution of the output file, if you would like to use, for example, 30 meters resolution, less than that, more than that, it depends on your work, on the accuracy needed from your work. And then let's go down. Here there is an important field for primary type of input data, which is the contour lines. It's not points, it's not spot heights, it's contour lines. And then you can say okay. Now the process will start down there. Okay, and now this is the final result. This is my digital elevation model, or digital terrain model, to be more accurate. So as you can see here, the color range here, you can change this, by the way. For example, go to topology here, you make it stretch, apply Now you have it in a different presentation. Most of you are more familiar with this kind of digital terrain models. Select any kind of color set here, etc. So you select what you like. So this is my final digital terrain model. We've done our work to a very good level of accuracy. Now, these white areas here, that means here we have a very high points. It is a mountain. As you can see here, the low 45 meters, the high 531 meters. Let's see some points here. I will get the identify point. The elevation of this point is 85 meters. This one 502 meters. This one 213 meters. And here I have very low points, I believe, yeah, 68. The darkest, the lowest, etc. And here I have some high area, 365 meters, etc. You would like to generate a hillshade from this digital terrain model now, from this raster image that you have. You can just here search for hillshade. Then try this one, input your raster data, this one that we have just generated, guys, here, DTM 25K, and then the location of your output. Then I will keep those as they are and then click OK. And this is my shaded relief, as you can see here. Of course, you can just change the colors, you can change the symbols used, etc. Okay, guys, so by doing that, we have converted the paper map, this one that we started from, into a final product, which is a digital terrain model, this one, as you can see here. And we did this by digitizing all the contour lines, as you can see here. I hope that you enjoyed this session, guys, which was about converting a paper map to a digital terrain model that you can use for a lot of applications in your study and work. Thank you very much for listening, and I will see you soon. Bye now.